Welcome back, everyone. We already saw how to use a recurrent neural network for a very predictable series like a sine wave. Let's go ahead and expand our understanding to work with a real time series dataset, one that has the index actually as date-time objects. And we'll see how to work with it not just with recurrent neural networks of Keras and TensorFlow, but also how to use Panda's unique timestamp capabilities to forecast timestamped points into the future. Let's head to a notebook and get started. Okay, here I am at the notebook. I've already imported pandas and NumPy and matplotlib. Let's read in our data set. We're going to be working with a data set from FRED, which is, if we come here to the link, it's the Federal Economic Database or Federal Reserve Economic Database. So what we have here is retail sales data for clothing and clothing accessory stores. You can see that there's a very clear cycle, and it looks like there's peaks around December, which makes sense because that's Christmas and holiday season here in the United States. So we're going to see if the recurrent neural network can actually end up predicting this sort of seasonality, just based off the historical data points. So we'll come back to our notebook. Let's read in that data. It's saved for you already underneath this data folder. So we'll say read in the data folder, and then it has a bit of a strange name. It's RSCCASN, and just go ahead and read it in as such. Now, if we just read it like this, you'll notice the data frame produces this date and then the actual value column. And if we check out the information here, the date is actually just read in as a string, and we want it to be a specific date timestamp. So we can make sure that by adding two more things. First, I can say parse dates is equal to true, and pandas will automatically look at strings that appear to be date times and attempt to transform them into datetime objects. And then I actually want this date to be an index, so we'll say index column is equal to, and then it's called date, so we'll run that. And now if we run information again, notice there's only one column now, and if we take a look at our actual index, we have a datetime index now. So the data frame now looks something like this. There's still just one column here, except the index is now a datetime index with the name date. Let's go ahead and, just for the sake of reference, rename the columns to be sales. That way it's easier to remember. And now let's go ahead and plot out the data. So we should be able to recreate the plot that's on that website that we just visited. And the notebook that we provide for you has all the links and information. So go ahead and run this, and we can see the data quite clearly here. Okay, so pretty much we're going to follow the exact same steps we did last time. So what we have to do is we have to decide where we're going to do our train test split. And for something like this, it's a lot more obvious where you should be doing your train test split. We should be doing a split at least a year's worth of information because there's clearly a yearly cycle here. We should try to forecast at least one of these seasonalities. So what we're going to do is let's go ahead and choose a little more than a year. We'll choose 1.5 years, or essentially 18 months. So let me check the length of my data frame. Notice it's 334, and if you look at these timestamps from the original data frame, if we just show it here, it's monthly data. So we have the year, the month, and the day. So we're going from month to month. So that means 12 rows is 1 year. So that means 18 rows is going to be 1.5 years. So we'll say the length of my data frame minus 18 is 316. So we'll go ahead and say my test index is the length of my data frame minus, and we'll go ahead and say test size. That way we can edit this in the future in case we want to play around with it, but I'll say 18 months is my test size. So now I have my test index, and just as before, we're just going to use this integer-based location and say, starting from the beginning, all the way to my test index, and then test, dfiloc, starting at my test index, go all the way to the end. And now I can see my training data goes from 1992 to 2018, sometime in April, and then my test data starts the very next month in May of 2018, and then goes all the way to October of 2019. Okay, so the next step is to scale our data just as we did with that sinusoidal data. And we can do this pretty easily by saying from sklearn, neoworksdigital.preprocessing import min-max scalar. Run that, and then we'll say scalar is equal to an instance of min-max scalar, and just as before, we only want to fit to our training data because we don't want to assume that we'll have information about the future data set. So we'll fit to our training data. Keep in mind, you may get a warning here. That's totally okay. And then what we're going to do is create the scaled versions of our data. We have the scaled training data, which is scalar.transform train. And then we'll have our scaled test data, which is scalar.transform test. Okay, the scaling is done. Now it's time to actually create our time series generator. Hopefully everything here feels really familiar given what we went over in the previous sine wave lectures. Let's import that time series generator. It's from tensorflow.keras.preprocessing.sequence. Import time series generator. And you should be using tab autocomplete just in case you do any typos here. You can always just copy and paste from our notebook as well. And so what we're going to do is let's go ahead and start defining our batches. Now, something to keep in mind here is I will add an early stopping and a validation generator. Because of that, I need to make sure that my actual length of my batch is less than the length of my test set. So recall that my current test set right now is 18 months. So I cannot feed a batch of 18 months and then expect to get a prediction of the 19th month with my test set. So my batches should be shorter than 18. Now, they can be 17, 16, 13, whatever you want. However, a pretty reasonable choice then for the length of my batch would be 12 months because that's a whole year. So we have length is equal to 12. And again, the length here, this represents the length of the actual batches. So let's create a generator and make sure we understand all of this. So we say time series generator, just as we did before. And the source of the x points comes from scaled train. The source of the y points is also coming from our scaled training data. And then the length of our batch is going to be equal to the length we just described here, 12 months. And as far as how many we're going to be passing in at a time, it will just be 1. So we'll go ahead and run that. Let's take a look at what the very first batch looks like, just to remind ourselves what's actually happening here. We say generator of 0 is equal to xy, run that, and then what we're going to say is, given the array of x, and remember this is a scaled version, 0, 0.2, etc. Notice it's going up, and notice it even has that seasonality. It comes back down, goes back up again, etc. And then what we want to do is predict that next value. Okay, so if we take a look at our scaled training set, you can see in the beginning here, we have those same values, and then right after 0.41, so if we scroll down to 0.41, we start again with that seasonality, come down to 0.02, and there it is. Okay, so given this batch, and if we take a look at the length of x here, whoops, the length of, so it has double dimensions, so the length of the x inside, notice that it's 12. So it's basically saying, given the length of 12 months, go ahead and predict that 13th month. Okay, so we understand x and y. It's essentially the exact same idea that we had before with the sine wave. So what we need to do is we'll go ahead and create our model, and then we will add in the early stopping by creating a validation generator, and then we can evaluate our model. So what we're going to do is in the very next lecture, we'll finish creating the model, get that early stopping callback, create the validation generator, and then evaluate our model's performance. If you have any questions on this, make sure to check out our notebook, and also make sure to just understand what these variables are actually representing. The length is the length of the batch here. The batch size is the fact that we're just essentially getting one array for x and one array or one value for y. If you were to change this to something like 2, then you would get 2 sets for x and 2 sets for y's. But in my experience, when it comes to time series sequences, it really works best with a batch size of 1, but there's no 100% correct answer here. You can always experiment. Thanks, and I'll see you at the next lecture where we create the model and begin to evaluate the model.